All right. Well, I'm happy Brian opened up with a vignette because given all the other talks I've seen today, this is going to be a little bit different in that I don't have like a piece of software that I'm coming that I think you all should use. And I certainly don't have some service that involves caching that I think you all should use. So you'll have to forgive me. But so I'm Nick Miner. I work in Dave O'Connor's group, for those who don't know, over at the Global Infectious Disease Laboratories out on Mineral Point. And we are fairly heavy users of CHTC specifically for doing environmental monitoring of pathogens. So the big thing that we're doing right now is we have about 50 cities that we get wastewater data from, and then we're basically trolling through that wastewater data to detect any and all human pathogens, and specifically viruses from that data that we can. So this means a data volume of maybe 5 to 10 terabytes per week, and we're basically everything that PIs in the lab are doing is pushing toward making that number higher and higher, which is so fun for us and for the great CHTC facilitators who have to keep hearing about how we overfill our staging server. But anyway, so yes, today I'm going to talk about using AI to deploy Nextflow on CHTC. Just a brief roadmap here. I'm going to start by making what I think is a completely uncontroversial point to everyone in this room, which is that the sciences have an enormous unmet need for software. They keep coming back with more software needs. I'm going to frame this in terms of how this affects individual researchers in particular, kind of breaking it out into two separate problems. And then I'm going to go into a perhaps clumsy attempt by me to use AI to solve some of those problems. And then I'm going to deliver, I think, basically a lukewarm, hopefully relatable take on using AI at this point in 2026. Perhaps that will be refreshing amidst all the hype that we're constantly a part of here. So anyway, here's the uncontroversial point. Like I said, the sciences have enormous unmet need for software. What does this mean? This means disproportionately that graduate students in labs, on top of doing science, also have to be equal parts scientists and software engineer. And the funny thing about that is that 99.9% of the time, those graduate students are not actually software engineers. They're not coming in knowing how to use like Git, right? And this is why, again, we have things like facilitators. So this leads to a variety of funny outcomes. Funny if you have a sense of humor like mine, where like the ecologist will lament that they got into this because they love being outside and they love plants and animals, but all they're doing is sitting inside looking at our studio with code that's breaking, right? So this is a very common outcome, and I'm guessing that most of you have known graduate students who are in this situation. So those graduate students and any researchers like them ultimately got into this because they want to do science, and now because their science requires so much computing, they have a couple of interrelated but subtly different problems. So the first problem is that it just takes a lot of time to get code working and to get data moved around and to get data moving through the code, right? So I will return to this as a researcher time problem. And then subtly related to that is what I'm referring to as the researcher agency problem. So researchers tend to have an idea of what kinds of problems are just past the line for them, where they don't have agency anymore. Interesting part of this, of course, is that sense of agency is perceived. So a researcher may be more or less correct about where they actually have agency. And that was true prior to the advent of AI-assisted engineering, agentic engineering, choose your buzzword. But these will figure prominently here. And of course, because we're talking in an AI session, I am unfortunately in a situation of saying the solution to both of these problems may potentially be AI software development, but it also introduces a variety of problems. And on top of that, there's the fact that like all technological transitions, it's just a little uncomfortable, right? Like going through this transition doesn't always feel good. And sometimes it's outright annoying because the people who are constantly suggesting AI to us are a little bit annoying about it too. So I just want to make space for the fact that in all technological transitions, there's always testing the limits of the technology itself, but there's also building social norms around the right ways to use these technologies. And so that's kind of all in the thought soup of my brain as I go into solving these problems. But anyway, so what's the problem? The problem is that Nextflow is this popular thing in the life sciences for making very complicated graphs of computational work. So this is an example of such a graph. If anyone knows Nextflow, they know that the Nextflow community is, oh, I just realized the timer is, oh, is there a timer here? Oh, okay. Thank God, all right. Anyway, so Nextflow people love their subway diagrams. This is a super common thing. You'll see a lot of Nextflow pipelines with subway diagrams in their GitHub READMEs. But anyway, so Nextflow is similar to SnakeMake. It has some similarities to Dagman, some similarities to WDL, and so on and so forth. But it's pretty big in the life sciences and bioinformatics, in part because there is this open source organization called NF-Core that established some early standards for how we should organize these things, how we should make them modular, how we should accept contributions, and things like that. For me, at least, as someone who has made many languishing projects that live on GitHub and have approximately 0 users and hardly 1 contributor, seeing projects with this many GitHub stars, but even more impressively, this many GitHub contributions for kind of a niche domain is quite impressive. And so I think that's why perhaps sometimes to our chagrin, people keep hearing about Nextflow, right? And we are part of the problem there. So we in 2021, because we were feeling FOMO from all the cool kids switching to Nextflow, we too started writing all of our pipelines for various bioinformatics-y things in Nextflow. And so now most of the data that we run through CHTC is in either of these Nextflow pipelines at this point. So what's the problem with Nextflow? Well, for CHTC at least, the problem is that Nextflow wants to be close to the code and the data on CHTC in a very simple way. So what do I mean by that? So I think everyone here will probably already know this information, so apologies. I'm sure this is also subtly wrong in certain ways, so apologies for that too. But basically, this is an oversimplification of a CHTC model where you have code that lives somewhere under a user home directory, and then you have data that lives somewhere under a storage directory that's big, and then you have actual compute that gets executed on nodes, right? And the key is that nodes have restricted access to different parts of the cluster. So most critically for Nextflow's purposes, nodes, when they're running, cannot necessarily access code if it lives in a user home directory. But you submit jobs from the user home directory, which means if you want Nextflow to submit jobs, submit little nodes for you, it needs to do that from the user home directory. Nextflow, to that point, wants to have this very simple model where code and data are freely intermingled. And so it's pretty common in Nextflow code to see the Nextflow basically freely accessing data, but also scripts from basically anywhere in the file system. And so it's very difficult to predict at the outset of a Nextflow pipeline where a dependency of that kind might come from. So this was very frustrating to us when we wanted to use CHTC hardware, but also wanted to use Nextflow, and the solution we came up with for it is it worked, but I think it's also in some ways the worst possible solution to this. Basically, what we would do is we would request from Condor one very, very large, ridiculously large node, and then we would run the entire Nextflow pipeline execution within that single node. And I see some laughs in the audience and some head shakes in the audience, which are both correct. Basically, we would wait an eternity for our nodes to come back. It would be very unpredictable how long it would take before we would get our nodes. We are poor citizens when we do this because we're soaking up all of these resources for such a long time. And a lot of the time, because Nextflow produces lots of intermediate files, those nodes were bound to eventually fail partway through anyway. And with this setup, we can't also take advantage of Nextflow's resume functionality. So we were yeah, we were suffering with this. The problem refined is that these Nextflow submitted nodes, they need access to files in the user home and staging on CHTC. And to fix this, I needed to change the Nextflow source code, which is scary. So now I have this problem, right? I have the time problem. I don't have time to learn the language that Nextflow is written in, which is Groovy. Show of hands who has written Groovy or heard of Groovy. Okay, that's actually pretty good. Groovy was hot at the narrow slice of time when Nextflow happens to have been started. So it is not hot now. So I do not have time to learn Groovy. Frankly, I also don't want to learn Groovy. There's no career benefit to me learning Groovy. So I definitely have this time problem. Oh, also I have a job, right? This Nextflow executor thing is a nice to have on top of the job. So what's that? Yeah, yes, I think Austin Powers is the creator, yes. And then I also, at some level, certainly a couple of years ago, I had a perceived agency problem, which is Nextflow is this big code base, it's this big project. This is scary. I don't want to, it's not my role to get into this, right? But since we got agents that could live in our terminals and our IDEs, this whole thing is kind of readjusting, right? We're kind of relearning what problems are actually hard for us. And so last summer, I was so frustrated with the downsides of this mega node situation that I took to my terminal setup. And yes, I am a terminal dork and I do everything in the terminal to start talking with agents in a setup that looks something like this with the agent on the right and then with a markdown document plan kind of thing on the left. And I cloned the Nextflow code base. I kind of got an overview of what the code base looks like, what modules I would need to surgically update with the constraint that the change, whatever it would end up being, would be non-breaking for other Nextflow users. Because my foolish hope was that the Nextflow maintainers would eventually upstream my changes, right? It took a few different prototypes of something to get working. Eventually we did get something working. And so this is a screenshot of it actually running on CHTC. This kind of display here, if you haven't run Nextflow before, is this nice little terminal user interface it provides with basically grabs onto your terminal and updates it in real time. And in this case, all of these progress indicators are actually each their own little Condor node. So now we've gone from a situation where we Condor requested a really big node, and then in the node, the executable runs Nextflow, to a situation where we're now on our AP running Nextflow directly, and then Nextflow is submitting the Condor submit files. And that was ultimately the goal. So ultimately, this did not culminate in something, because the solution is a little hacky. This didn't culminate something that even I felt should be upstreamed into Nextflow. So unfortunately, I am not a Nextflow contributor, sorry to say. But it turns out that Nextflow does have a plugin system, and they do have APIs that they provide specifically for executor plugins. And so we have created a plugin to serve this need so that we can still just use normal Nextflow and get Nextflow updates and things like that. Okay. So this is probably already obvious to all of you. The benefits are enormous here. It was totally worth going through this exercise. Nodes match in minutes. We use less resources, so there's more for everyone else. We get full resumability, so we can actually like add features to our pipeline and then test them out, which is amazing. And then running Nextflow on CHTC is basically the same user experience as like a technician running a Nextflow pipeline on one of our lab desktop machines. So lots of benefits to not doing that mega node thing. Returning to these two problems, right? So starting with the time problem, the interesting thing about this exercise is that at some level, it was still difficult to work through this problem in a way that produced something that would run on CHTC. So this was certainly not a direct solution to this researcher time problem, in a sense, right? we lump into this that I had to learn the whole Groovy language and learn the like Groovy development environment stuff, then yes, this absolutely solved the time problem because I didn't need to do that. However, it did take a week or two to get working prototypes and to send things up to CHTC and to get to convince some colleagues to try it and things like that. And so I would say that an outcome of this is that the time problem was not solved as strikingly as some people may claim, right? This was certainly not a one-shot afternoon, you know, make me a AI startup and make no mistakes kind of situation. So yes, time was saved, but it still took a non-trivial amount of time. This was still a software development process. But it's this perceived agency problem that I think might be the more transformative side of things within the sciences specifically. So I can just tell you with experiences like this and also some other things that we're working on in the lab, that having basically a fire hose of intelligence that we can point at any problem has radically expanded the software problems that we're comfortable with taking on. So I truly don't think we would have even touched trying to tweak Nextflow prior to the availability of these tools. And it made it tractable to do so, in large part because it could organize the information that we needed to make a dent in this problem, which might have been challenging otherwise. So, so the lukewarm take is problems that may have been somewhat easy previously, and I do consider this a somewhat easy problem. Writing and learning Groovy aside, it did not actually take that many hundreds of lines of code to solve this problem, right? So I know some lines of code can be the densest, trickiest thing you've ever tried to read and make sense of. So lines of code is not necessarily always the best proxy for how hard a problem is, but in this case, I would class this as a somewhat easy problem that just would have been annoying and tedious to address previously. And having AI-assisted development here just made it so that that somewhat easy problem became easier because we could plug those knowledge gaps faster. The extension of that is that hard problems like perhaps discovering new science or coming up with wholly new algorithms to address some of the data challenges that we might experience day to day, those problems are still hard. So I'm not, at least so far, I'm not yet seeing that part of my job being taken away just yet. We'll see though, we got new models this week, right? Okay, so of course, I think the open questions from these experiences are always some of the most interesting, right? So for me, the thing that I'm quite interested in hearing from other people about is, for example, what should our standards for reviewing this code be? How do we approach reviewing this code specifically when we're trying to poke problems in languages that we don't know, for example, or in domains that we don't know? How much knowledge is too little? Are we putting ourselves in a situation where we're just constantly experiencing this gel-man amnesia effect or whatever it's called? I think it's legitimately tricky to find the line there and to make prescriptions about what social norms should be across the board. But because our job is production of knowledge, we're kind of on the front lines of figuring that out, right? Another really tough thing, and this is tough for academia generally, is what does code ownership and maintenance, particularly long-term maintenance, look like? Again, I think academia has not tended to have a good story for this for a long time, and this is only going to make it worse, right? Because we can generate enormous code bases so much more quickly. So yeah, that may just get worse. We'll see. There's also, of course, replicability and reproducibility implications here. I think there's this whole personalized software thing or disposable software thing is really interesting. And for certain classes of problems, I think spinning up a quick little application that can give you an answer is something we've already been doing, and now we can spin up applications much more quickly. So maybe in those cases, replicability or reproducibility never really mattered that much and still don't. I don't know. TBD. And then the last thing that's kind of unrelated to these other questions that I'm thinking about a lot is, so I said I'm mostly a command line person. I don't see that changing for me necessarily, but I am interested in potentially software moving more in a direction where even if you're generating results that look like data, the results come with a GUI in a sense, that there's some kind of graphical user interface for it that's end user focused. This is something that more people are doing, and again, this leads to interesting, like people I think are fatigued of these AI like websites that get spun up that have lots of emojis and have a particular style and things like that. But I think data presentation is a hard problem, and this will certainly tip the balance and you know, in some kind of direction. But we will see what that is. So anyway, yeah, with that, I will thank my many guinea pigs from Dave and Shelby O'Connor's groups here at UW, and also Mark Johnson's group at University of Missouri. They generate enormous amounts of data for me to make a mess with and occasionally to clean up with. So just huge thanks to them again. And then also, of course, thanks to our funders and to all of you for being unwilling participants in this massive AI experiment we're in. Questions?
Hi. How big is the data that you're working with? I don't know if you mentioned it.
Say that again?
How big is the data that you're working with?
We do each week the major project we use CHTC for goes through 5 to 10 terabytes of data.
And that's through Nextflow.
Yes, it's through a stack of things, and Nextflow is one layer in the onion. But yeah.
So is there like an individual submission is gigabytes, or you're actually submitting like all 5 terabytes at once in a single data?
Not all 5 terabytes at once. Yeah, it gets parceled out into little pieces. Typically, each sample will be between 1 and 5 gigabytes. So there's lots of not so embarrassingly parallel parts to our particular problem.
First of all, I want to compliment you on your diagrams because no, I think they get to something really important. I liked how you demonstrate there's a different in conceptual model between what Nextflow is doing and what HTC is doing. And actually, I think one of the hardest parts of software engineering is getting to that conceptual model or explaining it to other people or figuring out why things aren't compatible, right? And one of the reasons we have so many workflow systems is that they have different conceptual models. It's not just syntax, right?
100%.
So as much as I'm not sanguine about AI, you know, I wonder to what extent AI was useful in either understanding that conceptual difference and not just getting to the fixing of it.
Yeah. Yeah, I think in our group and just for me personally, it's mostly a knowledge acquisition tool and then a planning tool. So I actually I do use agents, as I said, and occasionally I'll use groups of them, or I'll put them in a loop, which is the hot thing now. But most of the time that I spend using them tends to be in making planning documents and making diagrams, in finding prior art, and then having them explore those code bases and things like that. I do that because I believe that leads to better outcomes than the alternative. Different strokes, I guess I would say, but you know, if someone perhaps foolishly asked me for advice for how to use agents, I would definitely put them more in that direction than just the one shot, a solution to this thing, and then I'll just tell you what problems it has approach. Does that answer your question?
No, I think it's great, and I think there's something there about how do we get to an understanding if an ask is a little feature that fits the philosophy or if it's just contrary, right? I mean, have you asked Claude to modify Condor to support MPI?
No.
I thought that was going to be funny, but
yeah, it's a little funny. Yeah, you're welcome.
Thank you.